Welcome to MWN.com. Dr. M. Wilson is happy to welcome all to this session. Greetings from MWN.com. Dr. M. Wilson, author, publisher, professor of commerce and management and formerly vice principal and head of Department of Commerce, Nagercoil, is overwhelmed in presenting this session. Thank you. Please subscribe the channel MWN.com. Chapter 7. Measures of dispersion. The measure of dispersion is a statistical technique to find out the degree of deviations of data from the central tendency. The measure of central value of data like mean, median and mode give one single value which represents the entire data. But it fails to give complete description of the data. It does not explain how the variables scatter around the central value. Measures of dispersion give a complete picture about the degree of deviation of the data from the central value. This measure is based in the central values. Definition of dispersion. According to A.L. Bully, dispersion is the measure of the variation of the items. Pro. L.R. Connor defined dispersion as a measure of the extent to which the individual items vary. Spriegel states that the degree to which numerical data tend to spread about an average value is called the variation or dispersion of the data. W.F.L. Dick defined as dispersion or spread as the degree of the scatter or variation of the variables about a central value. John F. Griffin defines dispersion as a measures of variation or dispersion describes the degree of scatter shown by value. It is known from the definitions that dispersion means a measure of the degree of deviation or scatter of data from the central value. Objectives or importance of the measure of dispersion. 1. To find out the reliability of an average. The reliability of data depends on the closeness of it with the central value. Data is more reliable when it is closely related with the central value. Dispersion helps to find out the degree of closeness of data with the central value. If the dispersion is of smaller value, then the data are more close to the central value. If the dispersion is of higher value, then the data are more scattered from the central value. 2. To control the variation of data from the central value, it helps to know the causes and nature of variation, so as to control the variations. It helps the government to take suitable policies to remove the inequalities in the distribution of income and wealth. Companies can apply this method for policy making and control. 3. To compare two or more set of data regarding their variability, it helps to find out the uniformity of two or more set of data with regard to the degree of variation. If the degree of variation is low, it means the data are with greatest uniformity, reliability and consistency. Methods of measuring dispersion. The important methods of measuring dispersion are as follows. 1. Range. 2. Quartile deviation. 3. Mean deviation. 4. Standard deviation and 5. Lorenz curve. 1. Range. Range is the difference between the largest value and the smallest value of the variables. Hence, range equals largest value, smallest value. R equals L, S. In the given illustration, largest value is 90 and smallest value is 13. Hence range is 77 and coefficient of range is 0.75. Merits. It is very easy to calculate range. Demerits. Since only two values of the variables are taken for calculation, it is not a correct measure for dispersion. Quartile deviation. Quartile deviation is otherwise called as interquartile range. It is the difference between the third quartile and the first quartile, divided by 2. Hence, quartile deviation is Q3 minus Q1 divided by 2, where Q3 is third quartile and Q1 is first quartile. Coefficient of quartile deviation is Q3 minus Q1 divided by Q3 plus Q1. The values of n may also be obtained through the equation. Q3 is median plus QD and Q1 is median, QD. The formula for quartile deviation and coefficient of quartile deviation are same for individual observations and discrete series. Calculation of quartile deviation. Formula for quartile deviation for individual observations and quartile deviation for discrete series are mentioned here. For discrete series, cumulative frequencies to be calculated and from that the first and third quartiles should be identified. Discrete series contains variable like marks etc. and frequency that's number of items. Quartile deviation for continuous series. First of all, cumulative frequencies to be calculated and from that the first and third quartile classes can be known. It can be calculated as follows. After that Q1 class interval can be identified as Q1 is n by fourth item. Then, first quartile can be calculated as mentioned here. Q3 class interval can be identified as Q3 is 3n by fourth item. Third quartile can be calculated as mentioned here. Then the formula should be applied to no QD and coefficient of QD. Calculation of quartile deviation for individual observation is well explained here. Illustration is with marks and number of students. It's a discrete series. 3 columns table should be prepared. First 2 columns are as given in the illustration. Third column is for cumulative frequency. In the first row 5 is written. Then 5 plus 9 is 14, then 14 plus 13 is 27. Like that, all other rows should be calculated. Calculation of quartile deviation and coefficient of quartile deviation are well explained here. Quartile deviation and coefficient of quartile deviation should be calculated with 3-column table. First, to ascertain the cumulative frequency. The calculation seldom explains the way of calculation of quartile deviation. Merits of quartile deviation. 1. It is superior to range as a measure of dispersion. 2. It cannot be affected by extreme values. 3. It can be measured for open-end distribution. Demerits. 1. It is not capable of further algebraic analysis. 2. Sampling fluctuations affect much of its value. 3. It is not a good measure when the degree of variation is high. Mean deviation. Mean deviation is otherwise called as average deviation. It is a measure of deviation based on all the items in a distribution. But in range and quartile deviation only 2 values are taken into consideration. Mean deviation may be defined as the arithmetic average of the series. While calculating of the sum of the deviations, minus should be ignored, that's it should be treated as positive plus value. Calculation of mean deviation. 1. Mean deviation for individual observations. Mean deviation is modulus d divided by n. Modulus d indicates the sum of deviations from the mean or median or mode, can be read as modulus d. N indicates the total frequencies. Coefficient of mean deviation is mean deviation divided by mean or median or mode. For calculating coefficient of MD, divide MD by mean if deviations are taken from arithmetic mean, or divide by median if deviations are taken from median, or divide MD by mode if it is taken from mode. Mean deviation for discrete series. Mean deviation is sigma f into modulus d divided by n. Mean deviation for continuous series. Mean deviation is sigma f into modulus d divided by n. The deviations of the midpoints of class intervals from mean or median or mode should be multiplied by the respective frequencies. Then the sum of these deviations should be divided by the total number of frequencies to get the mean deviation. The formula is same for discrete series and continuous series. The illustration given is related to the calculation of mean deviation for individual observation. First, arithmetic mean should be calculated by adding all the variables and it should be divided by the total number. In the second column, modulus d should be calculated by deducting the variables with 30, which is the arithmetic mean. The minus is considered as positive 1. Here mean deviation is to be calculated from mean, median and mode. Data represents individual observation. Hence 4-column table should be prepared. First column variables should be written. In the second column, modulus d based on mean is calculated. In the third column, modulus d based on median is calculated. In the fourth column, modulus d based on mode is calculated. Here all calculations are given. This illustration represents a discrete series. 6-column table should be prepared. First column is income, second column is F, that's number of workers. In the third column, deviations from assumed mean is calculated and denoted as D. Fourth column is F into D. Third and fourth columns are for calculating arithmetic mean. Modulus d is calculated in fifth column. Last column is F into modulus d. Arithmetic mean, mean deviation and coefficient of mean deviation for illustration 7 are calculated here. Illustration 8 represents data for continuous series. 7-column table should be prepared. First column is variable represented as x, second column is F, that's frequency. In the third column, mid values should be written. In the fourth column, deviations from assumed mean is calculated and denoted as d dash. This is due to the adoption of shortcut method. Fifth column is F into d dash. Fourth and fifth columns are for calculating arithmetic mean. Modulus d is calculated in sixth column. Last column is F into modulus d. After that, all calculations are done. Merits of mean deviation. 1. It is easy to calculate. 2. It takes into account all variables of the distribution. 3. It will not be affected by the extreme values. 4. The fluctuations of samples will not affect the calculation of the mean deviation. Demerits of mean deviation. 1. It is not for further statistical analysis. 2. It is a non-algebraic method since the negative signs for the deviations are treated as positive. 3. It is not a popular method. Thank you. Please subscribe the channel MWN.com.